As we continue in our geometry, we are going to be talking here in 2-3 about two-dimensional figures. So things to think about. Up until now, we have worked with these, we have utilized these in previous grades, but we'll go through them all. Definitions. We are going to have a series of definitions. Geometry is just vocabulary centric, but we need to understand what is perimeter, what is circumference, what is the areas of our two-dimensional figures, and later on three-dimensional figures where we find the volume. And then the reason we do this is because we try to attach these geometric figures to real world items, allows us to work with them. So looking here, I will tell you that we will be utilizing, and you have a copy of the state reference sheet for the math course, for the math test. Your formulas are on there. They may appear to be a little bit different than the formulas that appear here in this material, but we will use those reference sheets throughout the class. And the big thing is to understand what is on my reference sheet, how do I fill in the information, what information does it give me, and how to work with that. Just because we have it doesn't mean that we can do anything with it if we don't work with it regularly and understand ahead of time. So keep that in mind as we are going through here. Some of these formulas will be available to us, and some of them we will have to learn, or memorize. So as we begin, perimeter, a polygon, let's go there. A polygon is a closed plane figure with at least three straight sides. So a polygon, poly means many, gon, many sides. So a triangle, 3 sides, 1, 2, 3. A square, 1, 2, 3, 4. Things that we know that, for example, a square has all 3 sides are the same. And of course, looking at this, that means that my corners are right angles. Rectangle, similar, where we have 2 opposite sides are the same, and then of course my angles are 90 degrees. Being able to look at a triangle, of course we do have 3 sides, but understanding what is going on here, that we would calculate the outer sides to find the perimeter. But if we were going to look at area for this, the area formula right here is area is equal 1/2 times base times height. And here they've got it labeled your base. This is your base, and then your height is going to be that vertical distance, that altitude that is 90 degrees from your base. So being able to calculate those items. So perimeter. Perimeter again is the sum of the lengths of all the sides. Sum of the lengths of all the sides is my perimeter. Think about your fence, a fence in the backyard or front yard even. That is perimeter. Your fence would make a perimeter. Now the yard that is fenced in would be considered the area that is being fenced in. So think of that, your perimeter, fencing, walls, your area would be the floor or the yard. Circumference really is nothing more than the perimeter, but of a circle, because a circle doesn't have any straight sides. It's a series of points equidistant from a center, so it is the circumference, and we have that formula, which is not available on your Tennessee reference sheet. So those are some of the things that we'll have to look at. The circumference of a circle is equal to 2 times the pi times radius, which is the same thing as the circumference is equal to pi times the diameter, because in a circle, your diameter goes all the way across and your radius goes from the center of the circle out. So in essence, we have a radius here, we have a radius here, and that would be why diameter is equal to radius, or a radius is 1/2 the diameter. So just understanding that. So radius is 1/2 the diameter, or the diameter is 2 times my radius. And then there you go. So we're going to work with these. We'll go over some of these as we are going on into this section. Equilateral triangle. Equilateral triangle just means all my sides are going to be the same. They're going to be congruent. Equiangular simply means that all the angles will be congruent. For example, a rectangle rectangle, a square are equal angular because of all the measurements, the angle measurements are 90 degrees. So just keep that in mind. And then a regular polygon is a convex polygon that is both equilateral and equal angular. Okay, and we'll talk more about that, but square would be an example. It has all the same sides, equilateral, and then it also has all the same angle measurements. Okay, and again, we'll get into more of that. So those are our big definitions, and then here we go. Now, when we talk about finding the perimeter, the circumference, the area, they have jumped right into using the coordinate plane. And on the coordinate plane, in order to find the length of something, you have got to use the distance formula. And I may not have stressed this before, or I have in class, that the distance formula is on a reference sheet. So you don't have to memorize it, but you definitely know how to use it. So just keep that in mind. And then here, so if we want to find the perimeter or the circumference, so here we're talking about perimeter. They tell me that it is a rectangle. So in a rectangle, I know that this side is going to be the same as this side. This side is going to be the same as this side, because that's what a rectangle does. Those are the characteristics. So in order to find the perimeter, I need to find this length, and then I can multiply it times 2, and then I need to find this length, and I can multiply it by 2 to find the perimeter. So what they've done here is, again, the length is going to be, they've used which 2 points? They've used A and D, and then so this is my A1, or A, X1, Y1, X2, Y2. They've plugged in the values, they've come up with my simplified, right? Plugged in the values, they simplified, and this turns out to be the square root of 50. Or if you simplified it, we talked about that a little bit previous, that would, think about it, that would be the square root of 25 times 2, and then we know that the square root of 25 is actually 5, leaving behind the square root of 2. It just depends how you're going to do that information. And let's see what else. Then finding the width, they did the same thing. They used A and B. So right here, they used A and B. They kept A as X1, Y1, X2, Y2. They did the substitution, they plugged it in, and it turns out that this is going to be the square root of 32. And then now that we know this side is the square root of 32, then I know this is the square root of 32, this was the square root of 50, and this was the square root of 50. And I could add all those up, or to do the formula is the perimeter is equal to 2 times the length plus 2 times W. So we had 2 times the length, which was square root of 50, plus 2 times W, which was square root of 32. And then they plugged that information in and simplified it using rounding with a calculator and came to 25.5. There you go. So the perimeter is about 25.5 units. And then for the area, since we did calculate the length and the width, we just substitute those in, multiply them across, let the calculator do the work for you. The square root of 1,600 is going to be 40, so the area is going to be 40 square units. Difference because we have the area, which is length times width, so we're multiplying our units. Units times units would be squared units. So there you go. Being able to utilize that information. And I will just say that on our lesson today in class, we will have some problems that will label everything for you. For example, I have a rectangle, and they tell me that the width is 5 and the length is 7. Okay, we'll do a couple of those just to use the formula first, then we will move into doing the coordinate plane, adding that next level of challenge to it. Okay, now for a circle, we're looking for the circumference, and the area. For a circle, in order to find the circumference, let's see, do they put it down here? They do. Here's my circumference, but I'm going to be working up here, so I'll just include it. The circumference is equal to 2 pi r, which is 2 times pi times radius. And then the area is equal to pi times the radius squared. Well, in order to solve for circumference or area, I need to have the radius. The radius is going to be a point that goes from the center of your circle to the outer edge. Okay, so look at that. Looks sort of like I have two endpoints on a line on the coordinate plane. So I can use the distance formula to find that. So this would be my x1, y1, or I guess x2, y2. This would be my x1, y1. And now I can use the distance formula to find out what in the heck r is equal to, and that's what they've done here. And then once I do that, all I have to do is substitute in r, and then I can find both the circumference and the area. And that's what they've done here. So they determined using the distance formula that the radius was the square root of 29. Okay. And then they turned around and plugged it in. So you have 2 times pi times the square root of 29, and using the calculator, that comes to about 33.8. 33.8 units. Again, that is just length. So we are talking 1 unit. And then once they found the circumference, they could turn around and use the radius to find the area. So 2 times 29, the square root of 29 squared. So, you know, those basically become 1. So we have 29 pi, or 91.1. And again, this is units squared. Units squared. Whatever the unit may be, we've squared them. So with that, looking here, doing this one problem, to find the circumference of an area of a circle again, and the, let's see, circumference equals 2 pi r, the area equals, I will move it down here a little bit, the area is equal to pi r squared. So we have an endpoint on the circle, we have a center point on the circle. So my distance formula, x2 minus x1 squared, y2 minus y1 squared, and we're finding the square root of that. So radius is equal to that. So one moment, let's fill in the information. Okay, so using the center as my x2, y2, using the edge as my x1, y1, I went ahead and used the distance formula, plugged everything in, and I simplified, and it turns out that I ended up, I believe, with radius is equal to the square root of 58. Plugging that into my formulas, over here I have the circumference is equal to 2 times pi times r, square root of 58. So 2 times pi times the square root of 58. When I plug that in the calculator, I received 47.9 units. Actually, I think it might have been 47.85, but I rounded up to 47.9. And then, so using this radius to find my area, pi r squared, which is pi times the square root of 82 squared, square root of 58 squared. So 58 pi, calculator gave me 128.2 units squared. So just using that information. Now, if you're not tracking and you need practice and you don't know what the radius is, if you can't identify what the radius is, again, we need to learn these vocabulary words, because you can't use the distance formula. It doesn't do you any good if you don't know what the radius is to be able to use it in the formula. So with that, let's see here. Modeling objects and using two-dimensional figures. Again, being able to recognize things and understand what's going on. So modeling this two-dimensional figure, well, it looks like it is a plate. It is some kind of straight four-sided object, straight sides. And I would say that if I look at this and I know that this width or length is 12.5, this is 12.5, I hope when you look at that you say, hey, that I could model with the area of a square or using a square. Looks like a square to me. And then what are the perimeter and area of the serving platter? Well, the area is going to be, they say side squared or just length times width, side squared. So you have 12.5 times 12.5. And then the perimeter, I can either take and say 4 times the length of one side, or I could add up the sides 4 times. Okay, and again, the side is 12.5, coming up with, let's see here, 48, 54, I think. I hope. Or it could have just been simply 50. Should be 50 inches, right? 48, and then half of 4 is 2, so 48 plus 2 is 50, so 50 inches. And then that's what we're looking at here, being able to utilize these real-world items. Let's see here, in this check, looks like we have a cat and what we affectionately called back home a Mississippi trash cat. So looking at this, hopefully you can say it looks like it's being modeled with a rectangle. And let's see here, two-dimensional figure that can be used, a rectangle. And then on our sheet, we know that the perimeter is equal to 2 times my length plus 2 times my width. And then the area is equal to the length times the width. So looking at that two-dimensional figure can be used to model the what two-dimensional, the rectangle, the perimeter. It looks like the length, so we have 2 times 40.6 plus 2 times 61. Call this my width, call this my length. So we can plug that into the calculator. And then for my length, again, I have 40.6 times 61, and that would give me my area. So that's how we would come up with that information. So again, units, so we would just have centimeters for the perimeter, and then we would have centimeters squared for the area. Looking here, again, using these two-dimensional models, it looks like it's a model of Isaiah's cafe. So the new fire code states that there must be 15 square feet of free space for every customer in the cafe. How many people can be in the cafe at any time? So free space, thinking about it. This area right here is free space where you don't have objects in the way, okay? The counter is not considered free space. The table is not considered free space. The drink station is not considered free space. They're just talking about the opening floor. How much is there? Well, we could take, let's see here, find the amount of available free space. So what I would do is, you know that the total area of the room is basically the length times the width, okay? So the length times the width, but you have objects in the way. So what you could do is find the overall area of the room and just mathematically, we're gonna, we'll just say that, let's look here. The room is 1 unit is 1 foot, so I have 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it looks like this may be 15 by 15. It is. So 15 by 15. So I know the area of the room is 15 times 15, which is 220 feet squared. Okay, so now we have a starting off point, and what we have to do now is just subtract the information that is in the way. For example, here the countertop looks like it's 3 times, I think 10. Wait, 3, 6, 9, 10, 11. Okay, so 3 times 11, so we could do that and say, hey, that's 33 feet. So I need to remove that from my total area. Then I have to use the distance formula to find the length and the width here. So I can remove that. I can remove the space that is comprised of the counter to come up with that information. So that's what they're doing here. So they started off with the total area of the room, and then they just started whittling away that information. So let's see here. So with that, I think I've pretty much talked through what we could do here. Finding the area of the counter, right? 3 times 11, which is 33. Finding the area of the drink station, which is a triangle. So you have 1/2 the base times height. So base, they're just saying is 5, height is 6. So that is 1/2 of 30, which is 15. Finding the areas of the tables using the distance formula. So they have done that. This is the using the distance formula to find the length and then the width. When they take those two things and they total them together, the table is length times width, which is square root of 20 times square root of 5, which is the square root of 100, which is equal to 10. So those are 10 feet squared. So that's what they've done here. They've taken the total area of the cafe, they subtracted the counter, subtracted the drink station, and then subtracted 2 tables, and then they would come up with that final answer. Now, apparently, looking here, it's 157 square feet. If you needed 15 square feet per person, okay, so what they did is they said, I need 15 square feet per person. When they multiplied across, they said we can have 10.5 or just 10 people. Can't have 0.5 people. So they had to go to 10. If they rounded up and went to 11, they exceeded their allowed spacing. So that's it. So that's how we could come up with some of that information and work with it. And I am going to pass on this example. We'll cover it in class, but the same thing goes here. Monica is redesigning her backyard, and she has created the following blueprint to model her design. So here's my blueprint. What are we trying to find? Let's see here. Is there enough space for her dog? Okay, she wants to have at least 300 square feet of grass available. So in order to find square feet of grass, you can again find the area, length times width, and then start subtracting things. You have a circle shape here, so that would be my radius. You could construct this or take this and you could say, hey, I've got this rectangle right here. I can remove that. I've got this rectangle right here. I can remove that. I have another rectangle. I can remove that. This is a trapezoid right here, so you can remove all of that occupied space to see, does Monica have enough area for her dog that she is looking to have. So there's things that we can do. Sometimes some things take longer than others, but step by step, take it slowly, write the formula out, fill the formulas in with the information that you have, and see what is left over that you can work with. All right, so here we go. Off to our assignment.